So I've got 12:02. I think we'll go ahead and get started. Good morning, good afternoon, whatever it is for you. Welcome to the third session, the third of four sessions in the introduction to lumber dry kiln operations. I'll introduce myself real quick. My name is Rich Edwards. I'm a research associate at Northern Arizona University in the Ecological Restoration Institute in the forest. We specifically in the forest operations and biomass utilizations program here. And a quick announcement first up, just for folks that if you have been on our website, the SWERI, the website for NAU, you may notice, but if you haven't been on there, we have a workshop, actually a seminar. This is actually a workshop, but a full seminar that starts tomorrow. I'm sorry, Wednesday. We're leaving tomorrow. Starts on Wednesday. It's in person in Albuquerque, but there also is a virtual option where you can sign up for the seminar. It's a day-and-a-half seminar. Runs from Wednesday all day, the 17th of November, and then a half a day on the following day, Thursday, the 18th of November. And the title of our seminar is Innovations in Forest Operations and Biomass Utilization in the Southwest. And again, it's a day-and-a-half seminar. But if I believe, let's see if Damon yes, he did. Damon put the link in the chat box if anybody is interested. Just go ahead and copy that link and go to our web page there for the wood utilization seminar and see. But you can still register if you're interested. I believe up until the day of, I think. I don't know if Damon, if you could give some insight on that, but anyway, if anybody's interested, it's all the information's there. So again, it's on the chat in your chat box. Anyway, that's just wanted to make that announcement first off. You can view the agenda at that web page and see what it's all about. Yeah, we're heading over tomorrow. It's physically in Albuquerque, and but like I said, we also have a virtual option that you can sign up for if you can't get to Albuquerque. But anyway, we'll go ahead and get started. We're about 5 minutes after, so again, welcome. If you could advance the slide, Damon. Just want to go over some housekeeping items. And first off, you are muted. When you sign on, you're muted and your video is off. You're limited pretty much as a participant to use the chat feature, and we like to limit that to communicate with other attendees. And then right next to that, to the right, I'm sorry, usually to the left of that, on most screens is the Q&A feature, and that's what we ask if you specifically need to ask questions during the presentations to please use the Q&A tab there. And another point is we are recording this, and it will be posted online after the seminar. We have the first two of Patrick's classes are already posted, so you can go back and view those afterwards, or you can forward them to other folks that might be interested. Another thing is we can we have this session and then one more session next Monday, so you can reuse that same link for next week's session also. And if you are a member of the Society of American Foresters and you are looking for continuing forestry education credits, just make sure you type your name into the chat and mention CFE in order to get those credits. And last but not least, those materials, all the course materials are available on box. And Damon did get back. He said people are free to register anytime. Damon also just posted the box link in the chat also. So if you need to access those materials, there's some really good materials in there. Definitely worth looking at. I've downloaded all of them. That's some good stuff, Patrick, on there on the materials, extra materials. And anyway, so that's with that. I'll just go ahead and do a quick introduction for Patrick. It's Dr. Patrick Rappold. He's the regional wood utilization specialist, and he is with the U.S. Forest Service in Milwaukee, Wisconsin. And read this 3 times now, and he's graduated from Virginia Tech. We were just talking about the Virginia Tech area down there in between West Virginia and Virginia, right before the workshop. And he first worked in the engineered wood products sector down there, and later on for a hardwood lumber manufacturer. After that, he moved out to Arizona in 2011, and he spent 9 years there and worked with, I think I met him when he was with the Department of Forestry Fire Management. And he's worked with various public institutions working to support forest restoration efforts and by supplying technical and marketing assistance to forest products manufacturers within the Southwest area here. And today, as I mentioned when we started, Dr. Rappold is presenting part 3 of the 4-part series, and Intro to Lumber Dry Kiln Operations. And he's specifically tailoring this workshop for the challenges faced by forest products sector in the Southwest. So with that, I'll let Dr. Rappold take over.
Well, thank you, Rich. I am registered for that seminar this coming Wednesday, and I'll be attending virtually. Looking forward to hearing Jeff Holbrook talk about railroad transportation. Even in the region where I am, the Eastern region, Region 9, Milwaukee, we do have some issues with transporting forest products over rail lines. It's a big issue, so I'm looking forward to dialing for that meeting on Wednesday and Thursday, I believe it is. So today we're going to dive into the topic of relative humidity. We're going to understand why that's important, how we calculate relative humidity, and with that knowledge, we will then develop our dry kiln schedules. We'll go through a couple different schedules that are publicly available, that are published by the Forest Products Laboratory, and we'll go over those schedules. And then we'll also make a schedule of our own, sort of fine tune based upon some recommendations. And then towards the bottom of the hour, the second hour, I will talk briefly about some phytosanitation techniques and regional phytosanitation issues. So if this is your first time dialing into this seminar, I am Patrick Rappold. I work for the USDA Forest Service in Milwaukee, Wisconsin. I did work within the industry for about 4 or 5 years for various companies. The last company I worked for was a hardwood lumber manufacturer in Southwest Pennsylvania, where I worked as a lumber dry kiln technician. We dried on average about 26 million board feet of different hardwood species annually. And we had in our capacity about 25 lumber dry kilns. So lots of lumber and lots of adventure with that particular occupation. So before I jump into my topic, I just do want to make everybody aware that The Forest Service is currently accepting applications for the Wood Innovations funding programs. The Forest Service started taking applications on October 19th, and they will stop. The deadline to submit your application is January 19 of 2020. So not much time left. Make sure you get your applications in. And let's see, it must have been last Tuesday, November 9th. I was part of a webcast, a pre-application webcast where we talked about the funding mechanisms and how to apply for it. And we answered a bunch of questions. And so I did have a recording of that available. And so I'll put that in the chat area for everybody to visit. There was some issues with the audio in the first 8 to 10 minutes of it. It's not super unbearable audio issues, but just be aware, once you get past the first 10 minutes or so, then it does, the audio does improve, and you can get lots of information from that webcast. So if you are applying for a Wood Innovations grant, these are your contacts. So if you are in Region 3, which is Arizona or New Mexico, it would be Mark Estrada. So Mark's based out of the Albuquerque office. If you're in, say, Nebraska, it would be Region 2, and that is Laura Wolf. So don't send your applications to me. Make sure you send it to your appropriate Wood Innovations coordinator based upon your geographic region. And because this is a Forest Service sponsored webinar, I do have to talk about discrimination. So during this webcast, we are not allowed to discriminate of any sort. If you do believe discrimination did take place, then there is a contact information there at the Office of Civil Rights. And so you can go there and file a notice if you need to. And USDA is an equal opportunity provider, employer, and lender. Antitrust issues. We're going to refrain from discussing pricing issues, pricing trends, buying trends. I will generally talk in terms of examples, generalities about prices and markets, but within the chat area and within any other presentations we have on this particular webcast, we're going to try to avoid any antitrust issues. So books for this week, definitely the Dry Kiln Operator's Manual is still the go-to reference. I'm going to add the dry kiln schedules for commercial woods. And so that there is a PDF version of that available. I'm going to reference that a lot this week. And so between the Dry Kiln Operator's Manual and the dry kiln schedules for commercial woods, there is a lot of published dry kiln schedules in there. And so that's what I'm going to be particularly referencing. And so you can download those now or later. Just some highlights from week 2 of what we did last week. We talked extensively about moisture content calculations, sample boards, how to calculate moisture content, how to estimate moisture content, and how to monitor moisture content. We also talked a lot about dry bulb and wet bulb measurements. And so this will be the sort of jump off for this week's topic of relative humidity, and that you really do need to have good, accurate dry bulbs and wet bulbs. And so they can be calibrated routinely. I recommend that with your a hygrometer to validate that you are accurately recording and reading the correct dry bulb and wet bulb temperatures. And just a reminder for your wet bulb wicks, which is what this is, make sure you're always cleaning it and don't let mold or any other junk form upon your wet bulb wick. Make sure you're washing it weekly and consistently. And that recommendation for maintaining clean wet bulb wicks also applies to your hygrometers. You simply will not be able to accurately calibrate your dry kilns unless you really maintain your equipment. And when you are drying very, very high priced, high value wood, it is very important to have very good controls. We also talked last week about data collection. So where does the data go? How do you maintain it? How do you keep it? And so we'll also be building upon this data collection philosophy, this data collection applications. And so most dry kilns these days that you can buy commercially do come with a PC Windows interface. And so there is the ability to store information, the ability to control the dry kilns from the computer database, from the computer station. And for the more advanced systems, you can also remotely operate and collect data from the dry kiln, whether you're at home or at someplace other than where the dry kiln physically is. So equilibrium moisture content. So I'm based in Milwaukee, Wisconsin, and the typical, inside moisture content of wood that is recommended is around 8%. So your typical indoor relative humidity of most modern homes is between 30 and 40% relative humidity. And so at that relative humidity levels, your wood naturally equalizes to different percentages. And so in most of the country, it's around 8%. In parts of the Southwest, it goes down to at least 6%. And then, in the timber basket of the Southeast, Mississippi, East Texas, it's definitely much more moist, more humid. And so that wood indoors tends to equalize a little bit higher at 11%. So why is this relevant? Why is this important to a person drying lumber? So in a part of the world where I live, there's a lot of snowbirds right now migrating to Phoenix, migrating to Tucson for their summer, for their winter homes. They're avoiding the long, dark, cold winters of the Midwest. And so a lot of times they will buy furniture from the Southwest and bring it back to Minnesota, to Wisconsin. And so you just need to be cognizant that, if you're drying lumber, if you're drying slabs, if you're making live edge countertops, talk with your customers, identify where that lumber is going, identify, where they're going to store that lumber. Is it going to be outside? It's going to be inside, just to get a better understanding of what you need to be targeting for your final moisture contents of your species. And so I primarily dried hardwood lumber. And so we always targeted around between 6 and 7%, sometimes as high as 8%. I don't know in the world of Ponderosa pine lumber if there's a regular target moisture content. I've heard that sometimes it can be as high as 11%. I think that's mostly for the molding and millwork industry. Ponderosa pine is great for that particular product. But if you are drying lumber and you have a target moisture content that you're consistently using, let me know what that is. I'm just interested to see what the target moisture contents are for our Ponderosa pine lumber producers. So again, just another table illustrating how these indoor equilibrium moisture content values can change based upon where you are. And so interior wood, the hardwood tables, the hardwood desks, the hardwood chairs, they typically are down to between 6 and 8% on average. The studs materials, the 2x4s in your walls, the rafters, those are a bit higher moisture content because they do have a slight interface with the outside, depending on how your walls are framed up. If you have vapor barriers or not within your walls. So that's just, when you're dealing with Ponderosa pine, sometimes it can be used for outdoor structural applications. Sometimes it can be used for indoor furniture applications. So it's just always good to know where your material is going and to dry it appropriately. Equilibrium moisture content of outside. So if you're storing lumber outside, say in Yuma, Arizona, if you got some Ponderosa pine that you dried and you're storing the lumber outside, it will equalize to a lower value than, say, if you're in Flagstaff, Arizona, based upon the relative humidity values of those general areas. And so you can see a big difference between Milwaukee, Wisconsin in July and even Flagstaff in July. We just have a lot more humidity in Milwaukee than Flagstaff and other areas in the Southwest. So Why is this important? Well, some of your wood products may be outside and inside, depending on the time of the year. If you sell a live edge bar top, that bar top may be outside during the summer months in Winslow, Arizona, where it's going to be super dry. And so that bar top may experience some movement. So that's why we always try to dry it to very consistent moisture contents throughout the lumber, and also apply some good finishes and lacquer to prevent moisture movement in between the membrane of that wood and the environment. And so, despite the highest performance wood coverings and lacquers, you can still have moisture movement. So I point this out just because it is relevant to especially people that are moving between different areas or have two different homes, and they're transitioning or regularly moving furniture and stuff from, say, the Midwest to the Southwest. So relative humidity, it is the amount of water vapor present in the air at saturation. And so the equilibrium moisture content does increase based if there is more relative humidity, if the relative humidity value is higher. And so empirically, we know this to be true. If it's hot and muggy out, we tend to see our door frames, our windows swell a little bit, but when we turn the furnace on in the winter, we sort of decrease that inside relative humidity. And so you do see the wood shrink a little bit. So with hardwood lumber, we typically dry around 6 to 8% moisture content. That would be equilibrium moisture content. And you can see that falls within that range of 30 to 40% relative humidity, which is typically what we see indoors throughout the 12 months of the year. So if you're drying to 10% equilibrium moisture content, you're targeting an environment where it's 50 to 60% relative humidity. And likewise, if you're, if you have an indoor pool in your house, or you have a lot of humidity in your house, if you have a large kitchen, you do a lot of cooking, and you're creating a lot of water vapor, you can non-intentionally increase the relative humidity in your house. And so you may get increased equilibrium values within your own house if you're, creating a lot of water vapor, if you're doing a lot of cooking, or, if you have, more than one or two full bathrooms where you have showers and baths running. So stud material, structural lumber, it's typically dried to around 18 to 19%. And so you can see how that correlates to that relative humidity. And so, when you buy studs at the Home Depot or any other lumber at these big box stores, that equilibrium moisture content will change depending on, the season of the year, if it is stored outside. So just trying to illustrate the relationship between equilibrium moisture content and relative humidity. Dry bulb temperature also affects equilibrium moisture content. And so if we go to 100 degrees at 60% relative humidity, we get equilibrium moisture content of 10.3. In most drying cycles for Ponderosa pine, most drying schedules will typically end up at an endpoint of 170 degrees within that dry kiln, and you're typically going to shoot for around 7%. So that means you would have a relative humidity value of about 55% at that particular target area. And so when you're drying lumber, these values, this dry bulb temperature, what you're trying to do is really decrease the relative humidity of that air within that dry kiln without raising the temperature too much. And so when you raise temperatures within a dry kiln, that's when you start to get some of the defects that occur. And so if you can visualize it, what you're trying to do is you're trying to simply move along this curve to where you're decreasing the equilibrium moisture content by lowering the relative humidity. And so how do you lower the relative humidity without increasing temperature? You can use your vents and you can use your fans. And so we'll talk a little bit more later about how to decrease relative humidity within your dry kiln to facilitate lumber drying. Relative humidity is a function of your dry bulb and wet bulb depressions. And so the wet bulb depression, I don't have a formula for it. It's simply the difference between the dry bulb and the wet bulb temperature. And so that's why you want to carefully and consistently validate the readings within your dry kiln with a hygrometer to make sure you're getting the correct values. This wet bulb depression will give you a lot of information about how your kiln's doing, how aggressive you are with the drying. And so typically when we start making the schedules, we'll be looking at the dry bulb temperature and the wet bulb depression. So this is a commonly used chart within the dry kiln community. I have one here that is laminated. And so if we were to meet in person, we would all have different, we would all have these nice laminated sheets I could hand out, and we could work off those sheets there. And so if you do start drying a lot of lumber, get yourself a full chart of relative humidity and equilibrium moisture content. Get it laminated and put it on your kiln chart wall so you can quickly reference these numbers. And so the numbers on top here that are not in italic are the relative humidity values based upon dry bulb temperature and your wet bulb depression. So if you have a dry bulb temperature of 75 degrees and a wet bulb depression of 10 degrees, that equates to a relative humidity of 58 degrees with an equilibrium moisture content of 10.5. So this is the fundamentals of creating your lumber dry kiln schedules, is knowing how this relationship is and how to calculate these. And so based upon this wet bulb depression, I can tell that my wet bulb value would be 10 degrees less than 75. So I have, at this particular example, I have a wet bulb temperature of 65 degrees based upon my 10-degree wet bulb depression. Another example, I'm going to hold that temperature at 75 degrees. So my dry bulb is going to remain at 75 degrees. But I'm going to increase that depression to 13 degrees wet bulb depression. So now I have a 13-degree difference between my dry bulb and my wet bulb. I have the air in that dry kiln now has more capacity to pick up moisture. So that equates to a lower relative humidity and a lower equilibrium moisture content. So I'd like to stop here for a minute, look up any questions. And Damon, if you could bring up that first poll question about, I believe I asked about drying stresses for people with their customers. And so if you could put that into the chat window, and we'll let that run let that populate for 5 minutes or so before I move on. Thanks, Damon. We'll let that populate. And so if anybody has any questions, I can, let me pull up the chat area here, the Q&A one. Not seeing any questions, I will move on and come back to that poll question in a little bit here. So moving on to dry kiln schedules. So there are two basic methods of creating dry kiln schedules. One is moisture content based and the other is time based. So with the moisture content approach to creating dry kiln schedules, that's what we've sort of been building up to for the last 2 weeks. We've been identifying how to create your sample boards, how to calculate moisture content. And so at least my recommendation for Ponderosa pine in the Southwest is to go with moisture content based schedules over time-based schedules. So time-based schedules are essentially where your set points, your temperatures, and your wet bulb depressions will automatically adjust, increase, and change based upon regular computerized programmed time increments. So it could either be time in kiln or time in a particular setting. And so typically the time-based schedules are used for Douglas fir, your eastern spruces and your pines, your spruce pine fir timber classifications. I have seen one dry kiln in Arizona use a time-based schedule. And I don't know if it was a true time-based schedule, but they had it laid out as a time-based schedule. I think they just had that particular oriented that way just because they knew their dry kiln so well and they knew their product so well that they could essentially go from a moisture content based schedule to a time-based schedule. And so if you're just starting out within the dry kiln business, you have your first charge of lumber ready to go, I would definitely go with the moisture content based schedule to just give yourself time to learn that kiln, learn how that kiln works. And, and also moisture content based scheduling is also good if you're given a new lumber species to dry. So, if you're down in Phoenix, you could be given some exotic woods down there, some of the non-native tree species that people plant down there in Phoenix. If you're into that urban wood utilization, there's a lot of sawmills in Phoenix that will take the urban wood and turn it into really beautiful items. But there's so many different species down there, whether it's fruit wood or just different woods that are trees that are planted. It's can be very difficult to do a time-based schedule if you really don't know your dry kiln or if you don't know your lumber species all that well. So let me pause there for a minute. And Damon, did you have any poll results you can share?
I didn't see any results come in for that poll, so I'm guessing the answer is no, but it's possible that our people that view the videos later are going to have experienced drying stresses.
Sure, and that's important, and there is a good collection of experts in the West that can help you with those drying stresses if you have questions like that. Just this morning, I was sent an email from a colleague in Colorado asking about some timber species up there. And so if I don't have the answer, we can definitely find somebody that does have the answer to those questions. So that's just a network of wood utilization specialists that we have across the country, including the specialists at the Forest Products Laboratory in Madison, Wisconsin. So stages of lumber drying. So what I want to point out here is, the first stage of lumber drying, you're essentially releasing a lot of that free water. It's pretty easy to get the water out of the lumber. And so until you get down to that fiber saturation point, it's you're usually pretty safe and you don't see a whole lot of checking or drying defects. But once you get down to around 25 to 30%, and I typically have always used 25% as the fiber saturation point. Damon, you recently graduated from a wood science program. I didn't know if the fiber saturation value has changed over time, or if it's always been 30%, or I've just always used 25% as the fiber saturation point. So I could be wrong on that.
As a general rule of thumb, I tend to think 30%, but it varies so much between species that I think in generalities 25 or 30 would be acceptable.
Right. Yeah. The 25% in my mind, I think, comes from my experience with hardwood lumber drying, where it's just more critical at that 25% moisture content level for hardwood lumber than say 30%. But yeah, it's somehow 25% got into my brain, and that's just what I go with all the time. And then just at the end of the drying cycle is the conditioning and equalizing. So essentially we took a bunch of water out of that wood. It did not dry equally across the different surfaces of that wood. And so what we have to do is equalize and condition that lumber to get a finished, final, stable product. So if you have a new dry kiln, or if you're developing a new drying schedule, these are some recommendations I can provide. Work with your dry kiln manufacturer. A lot of times they might have another customer drying the same kind of species as you, and they can provide some recommendations for creating an initial conservative drying schedule. You don't want to have a real aggressive drying schedule at first if you're just trying out a new dry kiln. And so I'll explain a little bit later about what makes a drying schedule aggressive and what makes it conservative. And as I said before, make sure your dry bulb and wet bulb are always calibrated accurately. Do it once a month, or after every charge, just to make sure that those RTDs, those resistance meters aren't damaged. sometimes you can run over the wires with your forklift. They get damaged with the loading and unloading operations that go into a dry kiln. And if you have a brand new dry kiln, make sure those vents are working properly. Walk around it, set your vents to 100%, turn your fans on, make sure everything's operational before you really put wood in there, because it's a lot easier to repair the dry kilns when they're empty than when they have wood inside the dry kiln. And as I said before, there is a lot of expertise out there to help you, with your wood utilization questions. And so you have a great resource there at Northern Arizona University. You have a great resource in Colorado, New Mexico, and at the national level, you have the Forest Products Laboratory, just a great network of specialists and information out there. So don't be afraid to ask for, request assistance up front before you do any damage to your wood or do any damage to your dry kiln. So just these are the two references I typically use for creating drying schedules: the Dry Kiln Operator's Manual and the Dry Kiln Schedules for Commercial Woods. I have both copies in my hand here, both hard copies. This one's been a little bit tore up right here, if you can see that. And then my other manual here, this is brand new. Just ordered this from the Forest Products Laboratory not too long ago. And so, these materials are available also in PDF if you prefer not to get a hard copy of those, but you can always, print out the drying schedules as needed. So these drying schedules were produced, or they were created back when, before forest restoration was even a topic. So these drying schedules were created with old growth species, large diameter timber species. They were, created when, wood had very little juvenile wood, it was all, just lots of sapwood, very free of knots and other defects. And so sometimes the schedules in these books can be characterized as aggressive, and sometimes they can be characterized as conservative. And so they are in general just references to start your own schedules. It's a leaping off point for a lot of people just to get their drying operation up and going. But don't completely rely on the drying schedules published in these books, because our timber's dynamics have changed over the years. A lot more small diameter timber being utilized these days, whether it's hardwoods or softwoods. And the scientists that created these publications, they didn't really foresee the predicament we're in now with catastrophic wildfire, and you're having to do forest restoration on small diameter ponderosa pine stands. And so as you look over these schedules, just be sure to realize that these are just benchmarks. They're just starting off points. Don't be very conservative when implementing and starting a new drying schedule, and especially adjust these schedules as needed if you're working with frozen wood or anything that's out of the normal. Especially like if you have ponderosa pine that's been killed by a beetle kill material will have a lot of wet pockets in it. So there's special drying schedules, there's special approaches to drying material like that. And what's really important if you're trying out a new schedule is to just monitor your daily moisture content loss rates. And so I think, I don't have any good numbers, but I've been told that for ponderosa pine, you can probably go up to a loss rate of 10% per day. And so I think that was for 4-quarter material. I'm not sure, but definitely monitor your moisture content loss rates. And ideally you want to get in your dry kiln every day, get a flashlight in there, check for any end checks, check for any surface checks, see if you're getting any mold. If you're getting mold in there, you definitely need to increase your temperature a little bit or increase your venting. And you can also increase your fan speed if you're starting to see some mold forming. And so it's just that daily, consistent being in the kiln, working with your lumber to really create that high quality product. So again, just another reference to this fairly comprehensive book about drying schedules. And so I'll show some of these schedules that are in this book here for ponderosa pine. And then I'll talk about how we built the schedules, how you can build your own schedule, and just how to interpret the schedules. So this is a drying schedule for Ponderosa pine. This is 4-quarter and 5-quarter stock. And so this table here does give you other recommended drying schedules for thicker material all the way up to 12-quarter, which is pretty impressive for Ponderosa pine. And it also gives you an anti-brown stain recommendation. So this is a little more aggressive drying schedule to prevent any brown stain forming. I'm not really an expert on stain formation in Ponderosa pine. I think as long as you're keeping consistent airflow across it, and you're keeping the temperatures above 110 degrees Fahrenheit, your dry bulb temperature, I think you can pretty much stave off a lot of brown stain. And so, if anybody has any questions about stain, I can do some background research on it and talk more extensively on it next time. But yeah, I would recommend just looking at the standard schedules before you go to any supplementary schedules. And so what you have here is this is showing that in table 238 of this particular book is the T9-C6 drying schedule. And so let's open up that and see what that entails. And so this is the T9-C6 drying schedule. And so it starts at above 40% moisture content, which is pretty routinely seen in Ponderosa pine in the Southwest. With your low relative humidity values, if you do have air dry material, that does drop down pretty quickly. But if the material is coming fresh out of the sawmill from freshly felled logs, you will typically see that moisture content above 40%. If you are processing cottonwood, say you get some cottonwood logs from the Camp Verde, Sedona area, you can see moisture contents in those freshly sawn logs above 100%. That's just due to that cellular nature of that wood. It can actually hold more water than it has wood cell material. So I see we're at about a quarter to the hour. And so what I want to do right now is just take a 10-minute break. And so if we can come back at 5 minutes to the hour, it just gives me a chance to take my voice to take a rest, and also just to get caught up in some of the Q&A. And so take a break right now and come back at 5 minutes to the hour. Thank you. Okay, well, welcome back. I try not to make those breaks too long. You know, since we are recording these sessions and people view them afterwards, you know, it just might not be as free flowing as, you know, if we take a lot of continuous breaks, but sometimes we do need to rest my voice a little bit. So essentially picking up where I left off, what we're looking at is the T9-C6 schedule for Ponderosa pine. So this schedule came from this particular book here. This is for 4/4 Ponderosa pine. So 4/4 is typically 1 inch nominal sizes. 5/4 would be 1.25 inches. 6/4 would be 1.5 inches. 8/4 would be 2 inches. And so this particular book here has a different recommended drying schedules for these particular species, and also some, you know, other categories. But let's stick with the T9-C6 schedule for right now. So the numbers in the schedule refer to very particular values created by the Forest Products Laboratory. So the T9 is the initial dry bulb temperature. C is the moisture content class. And the number 6 is the wet bulb depression class. And so I'll show some tables listing the rest of these a bit later. But just so you know, if you're just creating drying schedules, the larger your initial wet bulb depression is, it will equate to more aggressive, faster drying rates. And so if you're dealing with a species that you really don't know that well and don't have a lot of background on, maybe start with very low wet bulb depressions at the beginning, see how the lumber moves, see how the lumber works within your dry kiln before you really get too aggressive with your wet bulb depressions. So T9-C6, the T9 is the initial dry bulb temperature. And so this is for material above 30% moisture content. And the initial moisture content, it's a lot more relevant to the lower portion of this, the wet bulb depression, just because the wet bulb depression is sort of what drives your relative humidity values and will drive your drying rates. And then the C is for the wet bulb depression set points here. And so this is from the Dry Kiln Operator's Manual. If this is your first time seeing it, it can be a bit confusing, but you know, as you work more with drying schedules, you'll be able to create your own schedule, and I'll work through sort of creating your own schedule here in a minute. But so essentially, it's very important to know your initial moisture contents of your wood. So as we talked about last time, if you get material, if you get lumber, make sure you're doing your moisture contents, make sure you're getting your moisture sections like this one here into your ovens as quick as you can, getting them dried, just so you can, you know, quickly and accurately identify what your initial moisture content is of the material going into the dry kiln. So again, this is just the T9-C6. And so what I like to do when I write down a schedule is to do the wet bulb depression. It sort of gives me a better visual understanding of, you know, how aggressive that dry kiln schedule is. Like if I can see that wet bulb depression. But again, this equilibrium moisture content and these relative humidity values, these were all calculated based upon that EMC relative humidity chart. And so that's also within your Dry Kiln Operator's Manual. So let me just pause here for a minute. I did see a question in the Q&A window earlier, a question about wetwood. So I think sometimes they're called wet pockets or wetwood. And so that is a very common in your Western hemlock species. And I've been told it's also very common in your beetle-killed Ponderosa pine. And so what is the issue with wet pockets? The issue is that you will have very high and very low moisture content values within the lumber in your dry kiln. And so that is why you always want to have an appropriate number of dry kiln samples that you cut when you are starting up your dry kiln. So, make sure you're talking to your loggers, make sure you're talking to your lumber stackers, make sure you're talking to your sawyers to get a feel for what they're seeing in the lumber before you start that dry kiln. If they're seeing a lot of blue stain in it, that may be indicative of beetle killed material. And so you would want to take some of that beetle killed material that has blue stain in it. You would want to cut samples out of that and monitor that moisture content along with some material that is not blue stained. So that way you get a spectrum of moisture content distribution within that charge of lumber in your dry kiln. And so it's just knowing what's going on out there in the sawmill, what's going on in your dry kiln that really helps you create that great dry kiln product. So this is from the dry kiln operators manual. And so what they have here is another schedule recommendation for 4/4 Ponderosa pine of lower grade. So this would be your 2 commons, your 3 commons. This would not be your shops. This would not be your clear grades. This would be the lower grades. And so with the lower grades, it's typically assumed that you'd be willing, you don't have to, but you'd be willing to be a bit more aggressive with those particular lower grades, since they're really not that valuable within the marketplace. But as we talked about in our first seminar of our first week here, if you're doing forest restoration material, if you're processing that material, it's going to be of the 2 common variety. You're going to yield a lot of 2 common and a lot of 3 common. So you will be within the lower grades, but because you have a lot of juvenile wood within that lumber species, you don't want to be too aggressive with that material. So just some food for thought as you choose your drying schedules, and understand that the upper grade material, it's more of the outer core of the tree, the sapwood, the material that's free of defects, the material that does not have as much juvenile wood. And so that is just again, that's just a reflection upon when these drying schedules were created. The nature of forestry at that time, we were typically doing what they call industrial forestry operations. We were doing forestry for wood fiber procurement, and a lot of the forestry in the West these days is mostly for forest restoration purposes. So we really need to keep that in mind as we look at wood utilization moving forward, and addressing any updates to these dry kiln schedules that need to be updated or addressed. So we're going to essentially build this T9-A6 schedule, because this particular schedule is not in the dry kiln operators manual. There is no table for this particular schedule in any of the books I find. So we're just going to build this schedule based upon this recommendation. So it's going to be a T9 dry bulb, A class moisture content for your wet bulb depression, and then a 6 on the back end. So here is the charts, the tables from the dry kiln operators manual. So T9, this is starts with a 140 dry bulb temperature, and then your A moisture content classes for your wet bulb depression, it's an A. So that this is implying that the material is a little bit drier. So it's less, it's greater than 30%, but less than 35% moisture content. So this may be some material that's been air dried. And then a 6 is for your wet bulb depression set points in your step schedule. So using this table here, I was able to calculate or put the numbers, the values into this table. And so you can compare now the T9 C6 to the T9 A6. And so the material is coming in a little bit drier for this particular schedule. And I think that's would be fairly common in the Southwest in the summertime. If you're getting material that's been, if the logs have been on a log deck for a month, or if the if the material has been damaged by fire, maybe if the material came from fire salvage. And so just be aware that you can adjust these schedules based upon your inbound moisture contents, your initial moisture contents for the equilibrium moisture content values and relative humidity, again, I had to reference the EMC relative humidity chart. So that's why it's always important to have those charts available so you can fill in these tables and create your own drying schedules. So ramping up, starting the dry kiln up. So you can see the initial dry bulb temperature we want to reach is 140 degrees. And so how do we do that? It's generally recommended you go to 5 to 10 degree increases per hour to your final set point. And so our final set point up here would be 140 degrees. And so if we're starting at 80 degrees in the summertime with a dry kiln, it's going to take a while to get that up to 140 degrees at 5 to 10 degrees per hour. That is done so you're not overburdening your heating system. So if you have a wood-fired boiler that you're using to create steam to heat your dry kiln, you don't want to overburden that boiler. And so what I've seen in the past as an issue is if you ramp up very quickly, you will create your boiler will continuously be calling for fuel, for wood, and so you can actually create a lot of smoke that starts coming out of your boiler chimney, and so you don't want air pollutants. It can affect, it's just not good to be putting a lot of smoke out of your chimney just because you're trying to ramp up your drying schedules too quickly. So be aggressive with your ramp up, but don't overburden your fuel system. You don't want a slow ramp up, but you also don't want to ramp up to something that is going to cause your boiler operator to really not like you too much. So just be aware that ramp up conservatively but aggressively. And so know your boiler system and and also utilize the vents. So if it's February in Flagstaff or Snowflake, you're trying to warm up your dry kilns, maybe keep your vents closed. You can control your vents, keep the heat in there. A lot of times, if you're just starting up a dry kiln, and if it's a large dry kiln, sometimes the fans themselves will create heat, and you can actually heat the dry kilns up with just the fans running to kind of preheat that dry kiln before you put the lumber in there. But just as you see these schedules, it's tough to understand how to get to 140 degrees dry bulb temperature, when it's 35 degrees outside. So just be aware that you don't want to tax your fuel system, ramp up slowly. That initial free water will readily flow off that lumber. It'll evaporate very quickly in the beginning if it's above 25% moisture content, above 30% moisture content. And so just, be cognizant if you have a new dry kiln or if you have a new boiler system, just to take that initial ramp up very slowly, but, do it so, quick enough to where you're not going to get any issues with mold or staining. So it's a fuzzy area to discuss. I don't have a good answer for you, but just be aware that ramp up at a speed that does not exceed the ability of your heating system. So these are 3 topics that I see most overlooked in new dry kiln operations. So there's a lot of people out there that get into urban wood utilization, or they start salvaging some material from the forest, some logs, or they get into the custom sawing business, and then their business quickly grows and they want to start drying lumber. And so these 3 activities here, equalizing, conditioning, and siting the pitch, are 3 key activities that you have to consider when you're financing your dry kiln, when you're doing economics, when you're doing the business plans for your dry kilns. So if you're having a dry kiln built that uses direct fire heat, it's going to be a very dry heat. So it'll be very difficult to equalize that dry kiln without additional spray water vapor mechanisms. And so these companies do create water spray misting systems to put into your dry kilns if you don't have conventional steam heated dry kilns where you have moist air, where you have access to live steam, where you have access to high pressure steam, where you have access to condensate. And so dehumidification dry kilns are also the same. So that's using electric heat. Sometimes you're also using a dehumidifier. And so there is no, in a baseline dehumidification unit, you have to incorporate ways to introduce water vapor into that air to equalize and condition. So equalizing begins when your driest sample is 3% below the final moisture content. So this is assuming you have more than one sample within your dry kiln. I recommend at least two. Having one sample in the front of the dry kiln and one sample in the back is usually pretty good, sufficient to start with. But the more samples you have, it equates to more work, but it also equates to more data, which better data, more data usually creates better drying results. Conditioning is essentially relieving the stresses from the core and the shell of the wood. And so different ways of doing this, and I'll show some different ways here. But when you're in that conditioning phase, it is usually very high temperatures. It can, the highest I've seen is 170 degrees for Ponderosa pine, for hardwood lumber. And so what you want to do is be very cognizant of safety during the conditioning phases, because you may have to go into that kiln to get your sample boards. And so just be aware that, there is a big risk to be burned from the heat. You are having a lot of, the water vapor within that dry kiln. Also, the water vapor gets on your skin, it can burn. And so look at different safety regulations. I didn't bring any safety regulations here because I don't want to talk on behalf of OSHA or your local safety office. I would do your research to see what's required by OSHA within your region, locally or nationally, to work within these high temperature dry kilns. And so just be aware that when you're equalizing and conditioning, you are having live water vapor, sometimes high pressure, high temperature water vapor within that dry kiln. And so just be aware of that and act appropriately. So last session, there was a question about setting the pitch. And so setting the pitch is done within the kiln to essentially stop any of the sap from leaking out of the wood. And so in the rafters in my house, I have a house that was built in 1958. The rafters came from Canada because I have a grade stamp on there still. And so I can see some, it looks like golden crystals kind of forming. It's kind of a reflective color. And so that is the sap sort of oozing out of my rafters. And so what I interpret from that is that my attic has exceeded temperatures of 160 degrees at one point. And so that is typically when you get, if you set the pitch at 170 degrees when you're conditioning, that pitch will not be released from that softwood lumber until it reaches that same temperature. And so, my attic is not designed correctly. It gets a little too hot. It does affect my air conditioning. And so, it's just a matter of when you're setting the pitch, you're setting it to the highest temperature that you can, which is typically done during the conditioning phase, which is around 160 degrees, 170 degrees. And typically for most applications, that's usually a high enough temperature. Now, in some modern dry kilns that, process 2x4s, structural material, they get up to 219 degrees. And so that's a much higher temperature. You won't see as much sap coming out of those structural members if they were put into your attic today. So it's just it's a function of the drying technology of 1958 when the lumber was processed and put into my house. But again, if you're just getting into the dry kiln business, sawmill business, these are the top three issues I see with people trying to sell lumber, trying to market lumber. And so just be cognizant that just because you have a dry kiln, just because you have a sawmill doesn't mean it's going to be automatically profit. You have to go through these steps to make a consistent product. And if you're processing, say, cottonwood or or mesquite, there is no reason to set the pitch. Those, the hardwood species do not have pitch in them, so there's no need to set that pitch. Conditioning relieves the drying stresses. So I have a stress test right here. And so essentially what happened here is the shell dried at a faster rate than the core, which is what happens in dry kilns. And so the conditioning process, the conditioning stage will introduce moisture into that dry kiln to equalize the moisture content between the shell and the core. Very important step. So these are textbook conditioning equalizing strategies from the Forest Products Laboratory. And so if your desired final moisture content is 8%, you will start equalizing when your driest sample reaches 7%. And so it's, I'll say that again, because it is a tough concept to grasp if you're new to dry killing. So if your final moisture content is 9%, you want to equalize when your driest sample is around 7%. And so essentially what you're trying to do is you're trying to increase the moisture content in your lowest moisture content values of your lumber, and while still retaining the moisture content value of your higher moisture content lumber values. And so it's confusing, but what the equalizing stage does is it tries to equalize the moisture content across all lumber pieces in your dry kiln. And so you target your lowest, and you continue equalizing until you see your lowest value up to your desired final moisture content value. And then conditioning starts at after equalizing. And so then when you condition, you want to equalize, you want to target an equilibrium moisture content of 12% if you're trying to reach 9%. And so what that does, that's introducing additional air, additional moisture into that dry kiln to increase the moisture content of the shell. And so, we did all this work to dry the moisture out of the wood. And then at the final stages, what we do is we introduce water vapor, moist air back into the dry kiln to relieve these drying stresses. And so that's a critical component of the drying process. And it's very much overlooked by a lot of new or, dry kiln operators don't have a lot of experience. And so it's just something to be aware of. And there's a lot of information within the dry kiln operators manual. There's another book called Drying Eastern Hardwood Lumber. It really goes into depth into the equalizing and conditioning stages. And so equalizing and conditioning, it's a part of that drying process where you want to really be monitoring these activities closely, but also being aware that, at this stage of the process, your dry kiln could be 160 degrees, 170 degrees. And so just be cognizant of those high temperatures and your safety. So this is a modern steam dry kiln. This is a water vapor line. And so essentially water vapor or water is pushed through these lines at high pressure, and then it comes through these nozzles. And so dry kiln operators will not turn these nozzles on until they are equalizing or conditioning. And so during most of the beginning and middle stages of dry kilning of the drying schedule, these are turned off manually through an actuator, and these are not actively spraying throughout the entire drying process. You typically only turn your sprayers on, your spray lines on when you are equalizing or conditioning. And so those are them right there. And so this is the water pump. This is a university setting here. And so this is the apparatus that pumps that water into the chamber and through these spray lines. And so you can adjust the pressure of it. Adjusting the pressure of the spray volume, and I think it's measured in PSI. It does change the temperature of the water coming out. So yeah, I believe it's due to the friction of the water being forced through the nozzles that changes it. So if you have a high PSI system, I believe the temperatures will be slightly increased within that dry kiln when you are equalizing and conditioning. And so that's, it's something to be aware of. And, if you work with a dry kiln manufacturer, they will help you better understand these necessities to equalize and condition your lumber. So I've shown this image in the two previous webcasts we've done. So this is a homemade dehumidification dry kiln in northern Wisconsin. It has fans in it. It also has a dehumidifier in it, and there's also baseboard heating in it to provide a heat source to this. And so, like all lumber, this does have to be equalized and conditioned. And so what this approach here was to use a industrial garment steamer. And so this is an industrial garment steamer. This introduces a water vapor into the dry kiln, and the water is stored here. And it's electric water pump, and it comes out through here. And so we'll be talking next week to Scott Lyon with the Wisconsin Department of Natural Resources. And so Scott's has a lot of experience with this particular dry kiln, and using the industrial garment steamer to introduce moisture into this particular dry kiln. And so this is ingenuity at its finest. And so this is how you deal with adversity, is you find solutions to it. And I think this is pretty novel, and I'm sure they're willing to share this technology with the public. This is an institution. This is a learning institution in northern Wisconsin where this dehumidification unit is stored. So I just think that's kind of neat. But the steamer just goes right next to the dehumidifier. It plugs into the electrical outlet. And so if you're looking at dehumidification dry kilns, if you're looking at building your own before you buy a unit from a manufacturer, just consider up front, having to invest in a garment steamer to introduce moisture into that dry kiln. Now, if you're doing live edge slabs, thick material that is not going to be ripped or manufactured by a secondary manufacturer, it's not going to go through a rip saw, it's not going to be surfaced, then maybe you can get away with a little bit of internal drying stresses. So it's just a matter of knowing your final end uses also. And so if your live edge slab is not going to be put through a rip saw or manufactured into anything else, maybe drying stresses are not that important. It's just a matter of talking to your customers and seeing what their end uses are, and being willing to accept some criticism now and then about the qualities you're drying. It's just a matter of, you can't if you have a large market, if you're selling lumber and live edge slabs, that's a pretty large market. And so it's tough to really, dry to a particular moisture content for all of your customers. So I just put that out there, because if you start drying lumber, you will eventually get some claims. You will eventually have some customers that, say the product moved, or the wood failed in some way. And so it's just a matter of learning your market and adjusting your drying schedules and drying applications as needed. So this is how you evaluate if you have any drying stresses. And so this first one here, this is ideally what you want to see. This is free of drying stresses. Within the second one here, it looks like this core is doing some pinching there. Actually, that looks okay. I think it's not the greatest picture, but I think what this is supposed to illustrate is also a stress-free material, whereas this definitely has stress in it. And if you do introduce too much moisture and water vapor into your dry kiln, you can get what they call reverse case hardening, where the actual the core is drier than the shell, so it doesn't pinch the wood. It goes in a different direction. And so just this is how you evaluate the stresses. And so as you're doing your conditioning, ideally what you want to do is get a sample. You want to cut that sample and see if those drying stresses are in there before you stop the conditioning cycle. And so I'll show you quickly here how to so this is, oops, let's see. So this is, sorry about that. My volume's a bit high, but let me restart this video for you here. This is a pretty illustrative. So what you see here is Scott Lyons cutting a stress test, and you can see it pinch that saw blade right there. So that there's a lot of stress in there, and actually almost there's so much stress in that sample right there, it almost pulls that blade off that bandsaw. And so just that's how you do your stress test. Obviously, this charge right here needs more time conditioning, and so that's how you do the stress tests. So assuming you did everything correctly and your lumber is free of stresses, what you want to do is validate that, somehow, keep a record of that. And so what I recommend doing is taking a photocopy of your chart recorder and just, photocopying your stress-free sample right on to that chart recorder. That way, it's just, it's good record keeping on your part in case you do get a claim on your lumber, that you can, with certainty show that you did dry your lumber to stress-free conditions. And so just take your dry kiln chart, take your stress sample, not this one, but a better one, and put that on a photocopy machine and just photocopy that and put that in a file for that particular charge. So that's just a handy recommendation I can provide, for just bookkeeping and record keeping. So I'm going to jump into phytosanitation now, but before I do that, I'm going to ask Damon to put up our second poll question of the day, which is pertaining to phytosanitation stamps. So the question is, are you currently maintaining a phytosanitation stamp? So we'll wait for Damon to put that in there. Give that a few minutes to populate. So phytosanitation, I can remember when the country of Mexico changed its policies for importing green lumber to their country from the United States and also other countries. And so it happened on July 3rd, 2013. And so essentially what the country of Mexico did was say they are no longer going to accept wood products from the US unless it has a phytosanitation stamp on it. And so as you can imagine, that was a big it was a big hindrance initially to Arizona's and New Mexico's lumber industry, because they depend upon that export market very extensively. And so for a while there, we did work with APHIS. I was with Arizona Department of Forestry and Fire Management at the time. And so we did work with the Animal and Plant Health Inspection Service to talk to Arizona's forest industries about the phytosanitation process, what the new rules meant for them. Well, I think we had 2 or 3 meetings over in Nutrioso. I think we had 1 meeting in Xolo also. And I'm sure the industry associations in New Mexico also had similar meetings based upon the new mandate that came out in 2013 from the country of Mexico. But now I believe most exports of wood products, I think most manufacturers are automatically just doing the phytosanitation treatments in anticipation that they can sell their product more widely, more broadly. And I think most of the buyers these days are pretty much requiring all material to be heat treated, whether it's lumber or if it's pallet can't material or pallet parts. So I'm just going to go over some things about how this phytosanitation requirements do impact your lumber drying operations. So some of you may just be out there heat treating right now just for pallet parts. So you may not be going through all the moisture-based drying schedules. You may just be creating a lumber dry kiln just for heat treatment purposes, which is fine. There are some companies out there that offer very specific heat treatment chambers. So these are chambers that are designed to get up to temperatures very quickly, hold the temperature for a particular time. And so the heat treatment standard for wood products is 132 degrees Fahrenheit for 30 minutes, and that refers to the core temperature. And so the way you record it, the core temperature is you get RTD, you get a measuring device, you drill a hole within that pallet can or within that lumber, and you actually measure that core value, that core temperature. You have a data recorder someplace where you can record those values, and you can document that core temperature did get up to that particular set point, and it was held there for 30 minutes or more. And so if it's not possible to do the core temperature approach, you can work with a third-party agency to develop heat treatment schedules where you essentially have demonstrated through numerous testing, numerous kiln charges that this particular drying schedule that you created will create that core temperature and hold that core temperature for 30 minutes. And so what a lot of hardwood lumber manufacturers do is they essentially do the conditioning and equalizing process as part of the phytosanitation. So if I am conditioning at 170 degrees for 12 hours, I am easily meeting the requirements of this heat treatment standard. And so if that's the approach you're looking to take, then what you need to do is work with your local, your national lumber agencies to get that heat treatment stamp and verify that you can use those drying schedules. And I will provide some contact information for your local, regional, and national third-party agencies that can help validate your schedules and help you get your phytosanitation stamp. The other method besides heat treatment is methyl bromide. And so this is a methyl bromide tent. And so I believe Arizona and New Mexico does utilize a lot of methyl bromide for exporting lumber to Mexico. I believe most lumber that crosses the southern border goes through the Santa Teresa border crossing. I have been told there are methyl bromide tents there to accommodate the importing, exporting of softwood lumber, hardwood lumber. I've also been told there is dry kilns on the southern border, but I have not seen the dry kilns. It's probably worth a trip down there just to see those, see that apparatus and get a feel for, what the barriers or what the opportunities are for exporting lumber, green lumber, dry lumber across the southern border. Just one thing about methyl bromide, it is a ozone depleting chemical. And so I've been told, I started hearing this in 2003 that, methyl bromide will be phased out eventually for use, but I haven't seen that done yet. And I think in general, methyl bromide is pretty important for a lot of different agricultural markets. So I'm thinking that it's just being kept around because it is just so vital for, stopping the spread of insects and disease across the countries and borders. And I think there's other applications for methyl bromide also besides wood products, but just be cognizant of that. Essentially two different options: heat treatment or methyl bromide. I lean on the side of heat treatment just because it helps build dry kiln capacity in the Southwest, and it just gives you more options. It gives you more flexibility in the markets you serve and the product you provide. If you go with the methyl bromide method, you're essentially have to pay a third party to do that for you. You cannot do it yourself. That's pretty bad chemicals right there. And so, it's something that to consider. I believe a lot of the lumber brokers, will provide some estimates on what it costs for the methyl bromide treatment. So if you're working through a lumber broker by selling your lumber, methyl bromide, it may be the best option for you if you're just starting out with green lumber and don't have any dry kiln facilities yet. So again, if you do get your dry kiln schedules approved, you will need to document that your lumber went through a drying process. And so that is why I recommend retaining your kiln charts, for record keeping purposes. I've also seen some dry kilns in Arizona simply, provide a USB device to the heat treatment stamp agency as evidence that the lumber went through a heat treatment process. And so again, it just comes down to data keeping, record collection, how are you collecting the data, and is the data accurate? So always make sure you're calibrating your dry bulb temperatures and your wet bulb temperatures, your wet bulb RTDs, to make sure you can maintain your phytosanitation stamp. Very important for economics and very important for marketing purposes. So just showing here a typical control panel for a dry kiln. So this is where you could potentially save the drying information to a USB or some other format to show as evidence that you did implement that drying schedule and that the lumber in there has gone through a heat treatment. And I'm sure there's other methods out there. It's just a matter of working with your third-party agency. And so when I say third-party agency, there are companies out there that will provide a heat treatment stamp to you as a service. And so they will routinely audit your dry kilns. And so if you're doing moderate to large volumes, you will get a monthly audit from a person to look at your paperwork, make sure you're adhering to the requirements of your heat treatment stamp. So this is a stamp from Export Wood Packaging Inspection Services. This is a company that has an office in New Mexico and Florida. And so I'm sure there's several companies in New Mexico that are utilizing this service. I believe this is also I don't know if this is the same stamp you need for fuel wood heat treatment. I have seen some products in New Mexico that had a state of New Mexico stamp on it for heat treatment. That was a firewood product. And so I don't know if these particular stamps also carry over to fuel wood. I believe the fuel wood stamps are handled a little bit differently for validating that the firewood has been heat treated for insects and stuff like that. Well, just another great stamp, another heat treatment stamp. And this one is from the Northeast. So this is what I would see in my region. So this is the Northeast lumber manufacturers. And so this is it is a physical stamp you get. You get a stamp. It will have your particular mill number on it, your customer number. And so you actually there's rules and directions for maintaining that stamp. Keeping that stamp in a locked area. It's it's kind of a big deal. And so if you do go for the heat treatment stamp option, just realize that there's a lot of paperwork associated with that, a lot of auditing requirements, and but it's for the purpose of just keeping our forests healthy and free of invasive insects. So this is a heat treatment stamp by Timber Products Inspection, also known as TPI. So I believe TPI does have an office in Prescott, Arizona. So this is what I saw a lot in Arizona and New Mexico was a TPI stamps. And so, these are pretty big companies, but they definitely will service, sawmills and companies of different sizes. So, definitely look around and see what company is the best fit for you and what's best for your paper keeping, record keeping purposes. So this is also a grade stamp or a heat treatment stamp you see a lot in the Southwest and also the Pacific Northwest. This is the Western Wood Products Association stamp. So this is a very large third-party agency. This is probably the largest one in the West. They do a lot of grade stamp for lumber also. And so, just big, large company, lots of resources, and they can also help answer questions for you about phytosanitation and, validating your drying schedules and validating your heat treatment approaches. So bark, this is also overlooked by a lot of people. So bark in the form of wane or any form of bark that can be seen is definitely gonna be quarantined. So what you wanna do is as you're stacking your lumber, as you're processing your lumber, just always have a draw shave available to scrape any bark off as needed. And so you can keep some draw shaves on your green chain, on your sawmill area, just because if the bark, it doesn't matter if you have a heat treatment stamp, if you've done all that, there's still issues with bark. And so just just be forewarned that completely work to remove all bark from your wood, especially in the wane area. It's just going to tie you up when you are trying to export your material. It's just going to slow down that whole export process. So just be aware that work, just be cognizant that bark on the outside of the material is just not very good for getting that material across the border. This is just another photograph of that methyl bromide tent. And so I think there's a container of logs in there right now in this picture here. And so I think there's a set procedure to pump methyl bromide into the container, and then it is held there for a certain amount of time to kill any insects. And I don't know what this process costs, but I know it's done extensively in the Southwest across numerous border crossings, and also if you're exporting raw logs out from the U.S. to other countries, methyl bromide is also one of the preferred methods for phytosanitation of logs. But that's probably not done too much in the West because there's certain regulations about exporting raw logs from the Western U.S. So again, it's a bit more complicated than heat treatment. When you go with the methyl bromide, procedure, methyl bromide is pretty bad chemical. So it's not a do-it-yourself. It's not a one and done type process. There's a lot of bookkeeping there, record keeping. So just be aware that methyl bromide, it's done a lot, but there is a lot of upfront planning that has to be done for it also. So Damon, I'm at the end of my presentation for today. Can you show us the results from that last poll if there was any information provided? So it looks like no is the common answer across the audience today, that they're not maintaining a grade stamp or a phytosanitation stamp, which is fine. I mean, if you're just processing, say thick live edge slabs for bar tops, you may not need a phytosanitation stamp. And so that's definitely an option to have. And so this is week 3 of the course, the webcast on lumber drying operations. Next Monday, November 22nd, is our last and final webcast. And so on that, for that webcast, we're going to have 2 guest speakers. One will be from Nyle Dry Kilns to talk about their dehumidification unit. And then we'll also have Scott Lyon from the Wisconsin Department of Natural Resources to talk about vacuum drying. And so I'm bringing these guest speakers in to talk about vacuum drying and dehumidification drying, primarily because I am not that knowledgeable with those particular methods of drying. And so by having these guest speakers, join us, they can speak more on authority on this topic, and also, just better inform the audience, because I think you'll see a lot more dehumidification units in the Southwest in the future. I think they're fairly flexible. They're definitely lower in cost than, say, a full-fledged steam kiln, depending on what size you buy. They offer some flexibility over different units, different applications. And so, I invite you to come on next week and listen to our guest speakers. And so with that, I'd like to invite Rich and Damon on to discuss any issues that we need to before closing out for today.
I got a question for you, Patrick. On grade stamps, if you have a like KD in your grade stamp, now so dried, when it comes down to someone doing like an inspection on your grade stamp, because I know that I've been part of those inspections before at lumber at a sawmill. How much leeway do they give you on moisture content? Did you happen to know?
I do not know off the top of my head. I do have copies of different lumber grading rules in front of me here. This one's mostly for Western species, but I think it's a lot of just working with the particular inspector that comes to your facility. They are there to help you. They're, so they could be spotting issues such as, maybe you have too much distribution moisture content across loads and maybe you didn't notice that. And so I think, given those situations, your grading agency is going to work with you to help you create the best product you can. But, to directly answer your question, I really don't know the standards, but, there is always the option to re-dry some material in different methods, different apparatuses. And so it's a good question. And maybe one of our guest speakers next week will have a better answer than I have. So. And so I guess, I'll see you both on Wednesday of this week for your larger seminar in Albuquerque. And I would encourage everybody that is, on today's webcast to also register for that particular seminar. Damon, if you want to put that into the chat real quick there, we can, that link there, we can do one final plug for that particular seminar. And so with that, I will sign off today and look forward to next week. Thank you.
Thank you, Patrick.
Thank you.
Thanks, Patrick.